Hello, welcome to video 27a. In the last video, we looked at how to define training polygons and assess spectral separability in ArcMap. And our goal was to classify an image of Yellowstone National Park, which was collected right after a forest fire in 1988. So we're seeing if we can classify out the burned areas versus the unburned. So in the last video, we kind of got all of our spectral data, our training polygons, if you will, and we're going to use those to do supervised classification. Now in this video I want to show you a very quick and dirty way to try decision tree classification, which is basically a type of supervised classification. I'll give you a quick caveat now. We're going to do this using conditional statements in raster calculator. This is absolutely a cheesy way to do this. You can do this very effectively in Envy and other pieces of software. As far as I know, this is the only way to do it in ArcMap, and it's a little bit kind of delicate and inefficient, but conceptually it's basically the same, and it is doable. So we're going to do it. So I'll give you a quick overview of what decision tree is, and then I'll show you how to write those conditional statements in raster calculator. So decision tree is basically a flow of decisions. So you consider an unknown pixel that you're trying to classify, and you ask a question of that pixel. In this case, you'd ask, is the reflectivity in the near infrared less than 10% or is it greater than 10%? If it's reflecting less than 10% in the near infrared, that you could safely say it was water. And we're actually going to do that in this video. So then all pixels that had less than 10% reflectivity would be now classified as water, and those pixels are excluded from further consideration. They're done, and we're going to move on to the next pixel. But now if the next pixel comes in and it's greater than 10% reflectivity in the near infrared, then we have to ask other questions. So is it greater than 30% in the green or less than 30% reflectivity in the green? If it's less than 30%, we'd go to yet another question. In this case, the question would be, what's its elevation on the digital elevation model? If it's less than 800 meters, then it's probably an irrigated agricultural field. If it's greater than 800 meters, then it's probably trees up on a hillside. So using this question, we established that it was probably some kind of plants or vegetation, dense vegetation. Then using the second question about elevation, we decided whether it was probably agricultural or whether it was probably a forested hillside. So that's the idea of the decision tree classifier. It's very customizable, which is great, but of course you have to know what questions you want to ask at each step and where you're going to put your thresholds for decision making. Now in the last video we established some thresholds for water, meadow, forest, and burned. So we set up 4 kinds of pixels in our Yellowstone image, and now we're going to try to build one of these in ArcMap. So let's head to ArcMap. Here's our project. Here's the water pixels we collected. Here's the meadow pixels we collected. Here's the forested pixels, and then here was the burned area pixels. So those were our inputs, or our training polygons. And now we're going to set up a simple decision tree to see if we can identify these. And what we decided was that anything in band 5 with the digital number less than 15 was going to be water. Anything in band 4 with a digital number greater than 60 was going to be meadow. Anything in band 4 between 33 and 60 was going to be forest, and anything in band 4 between 17 and 33 was going to be a burned area. So the first thing we need to do, we're going to use both bands 4 and 5. So I'm first going to go to the image analysis window and actually just quickly extract those 2 bands using function chains. So I'll highlight my based Landsat area here, then I'll click on the function chain, I'll right click to replace the identity function, and I'm going to use just the extract band tool very quickly. I'm going to leave the input the constant, and we're going to get band 4 out first. Just hit OK, and then I'll hit OK. It gave me my output, which is just band 4. I'm going to just rename that band 4 so I don't get confused. Then I'm going to repeat that same process, and this time extract out band 5. And voila! Now I've got band 5 as well. So now I can use these as inputs into raster calculator, where I can build some conditional statements. We probably could do this in the image analysis workflow, but I think we're going to use raster calculator instead. So over here in my search tool, I searched for raster calculator. I found it. It's under spatial analyst tools, and we'll bring it up. And raster calculator is powerful because you can put in any equation you want into it. And the thing to always remember is that it's going to execute that equation on every pixel of the raster. So somewhere along the line, you're going to have to call one or more of these input rasters. And it's going to always assume the extent is the same as those input rasters, and it's going to do the calculation on every pixel in that raster extent independently. So it's going to repeat the calculation thousands of times. Now in this case, we're going to use a conditional statement. And the way these work is there's 3 entries. So first I'll double-click conditional to get it to show up. And the way this works is there's 3 entries that are going to be separated by 2 commas. Okay? In the first entry is actually the if statement. So it's not written out, but the assumption is that you say, in that first entry, you say if, for example, band 5, I'll double-click, is less than 15. Okay, so that's the if statement. If band 5 is less than 15, then, now to put in the then statement, we go to between the second pair of commas. Then, assign that pixel a value of 1. So I'm just going to put 1 in. This last entry is for the else case. What should we do if it's not less than 15 in band 1? In this case, I'm going to nest in another conditional statement. So I'll double-click it. So just to read this out to you, what we're really saying is if band 5 is less than 15, make the pixel value 1. Otherwise, execute this next nested conditional statement. Now in this case, I'm going to say if band 4 is greater than 60, call that pixel 2. Otherwise, nest in another conditional statement. And this next conditional statement is going to be if band 4 is less than 33, call that pixel value 3. Otherwise, call that pixel 4. And so now we've actually built in this logical flow where we've basically using the intervals we established in the previous video for water, meadow, forest, and burned area. We're now going to assign each of those a new pixel value. So if band 5 is less than 15, well, then it's water. Let's call water 1. Otherwise, now keep in mind, after that step, any pixel that was less than 15 is no longer going to be considered. But if it wasn't less than 15, let's look at band 4. If it's greater than 60, let's assign it a pixel value of 2. And of course, that would be meadow. So if it is meadow, then we don't consider that pixel further. But otherwise, ask if band 4 is less than 33, in which case that would be a burned pixel, and give that a value of 3. And if it's not that, well, then there's only one category left, and that would be forest, and we'll call that 4. So any pixel that didn't fall into any of these categories is going to be called forest. Now we'll give that an output name. Let's call it decision tree RC2, and then we'll hit OK. Before you hit OK, make sure your equation looks something like that, and we'll just wait for a second. Okay, welcome back. That didn't take long, and it's returned my classified image. I took a minute and I adjusted the colors so that they made sense to me. I made class 1, which was water, blue. I made class 2, which was meadow, a light green. Made class 3, the burned areas, black. And then I made class 4, the trees, green. So we can see right away it did great with water. If we just do a quick cross calibration here, we turn this on and off, you can see it really nicely outlined those water pixels because they had that really low reflectance in band 4. That was a no-brainer. But remember, we were worried about confusion between the burned areas and the trees. Those had the most spectral overlap. So let's zoom in here on a kind of complicated burned area, maybe right in here, and have a look at how well we did. So black is burned, green is unburned trees. And you know, actually it's really not too bad. We can see some areas like right in here where the fire appears to have not completely burned the trees. So there's still unburned trees in here surrounded by this rim of burnage. And you can see it actually picked those out pretty well. So all in all, not a bad job considering how unsophisticated that algorithm was. So that's it for decision tree classification. Join us for our next video where we'll look at some of the more sophisticated classification tools in ArcMap. Thanks a lot.